Excuse me. This is, find the integral of this here. Now, this integral has no limits, which means that you have to add on a constant, a letter of your choosing at the end, C or K, whatever you want, okay? Now, see the 5 here, okay? See the 5 here? We can put that on the outside. 5 times the integral of cos 3x. Now, the rule is any constant can be moved to the outside. If that was the letter m, and I'm told m is a constant, I can move the m to the outside. What you can't, however, move is the angle. The angle is fixed beside the cos. Now, you look up your tables and you go, what is the integral of cos x? And you'll be told that it's sine x. I don't have these learnt off, they'll be just in your tables, okay? So, you'll say it's now, the next thing is, if it's cos 3x, it's going to be 1 over the derivative of your angle. So it's going to be 1 over the derivative of 3x is 3, and your angle is always unchanged. So it's going to be a third cos 3x plus c. And you're talking maybe 10 marks for that. Okay?
Wait, so if there's numbers of the angle, the polar remains unchanged?
Sorry? Yeah, the angle, the argument never changes. The angle never changes.
Cos x changes sin x.
Yeah. Guys, sorry. The answer was actually, excuse me, it was actually sine. Yeah. Sorry. The cos changed to sine, so sine 3x plus c. My bad.
You know how 5 over
And yes. 5 is being multiplied by this. So you can do it 2 ways, okay? The first way you can do it is 5 times that is going to be 5 over 3 sine 3x. Now, it's also technically 5c, isn't it? Now, 5c is still just a random number that we're never going to know. So you can just call it, that's a correct answer, but you could also just call it, I'll just call it k instead, where k is 5 times c. Once you have a letter at the end, you're good. Okay? 5 is a number that it doesn't change. No, any number. It could be minus 7.3. It could be a fraction. The whole point is it hasn't got an x in it. See, 3x squared is a variable because it has x in it, because x can change value. While 5 or 1/5 hasn't got a variable in it, which means it's always worth the same value. That's what constant means compared to a variable. Okay? Now, excuse me guys, the next question is is a good one, okay? It's hard to visualize. Now, the slope of a curve. We have a random curve. I don't know if it's n-shaped, I don't know if it's cubic, I don't really know. Alright? But what I'm told is its slope. The slope is the first derivative, right? Its first derivative is linear. What does that mean about the original? Quadratic. So you're left with a choice of n-shaped or u-shaped. Okay? Now, for anybody who's trying to catch up with that is, when you differentiate an x squared plus whatever comes behind it, its biggest power is going to be x plus whatever comes after it. One of them's quadratic, the other one is linear. Next thing you want to realize is that, guys, we'll just do the series here. If your initial equation is a cubic, your first derivative therefore has to be a quadratic, and then your second derivative will be linear. Always that way. Now, what we're told is that the first derivative, so we have our original equation, y equals something in a box, and then we're told that dy dx equals 2x minus 2. What is the reverse of differentiation? Integration. So we're going to integrate this to the power dx. Okay? Yeah.
I think I have a faster idea of the integration.
Okay. Go for it. Now guys, you're going to integrate. When you integrate x, okay, remember when you differentiate x squared, it turns into x to the power of 2. So when you differentiate x squared, it's 2x. So therefore the reverse process is true. 2x turns into x squared. Okay? Next part after that is what turns into minus 2? When you differentiate minus 2x, it turns into minus 2. Now, there's also the presence of a random letter, a number here, that when it got differentiated, it just disappeared. So that's why it turned into nothing. So you got to include your k there. Now, what we're also told is that this curve has a specific point on the curve. The specific point on the curve is minus 2, 0. So when x equals minus 2, y has to equal 0. So 0 equals minus 2 squared minus 2 times 2. Sorry, minus 2 times minus 2 plus k. And therefore,
4 plus 4, k equals minus 8.
yeah, so it's going to be 4 plus 4 plus k equals 0. And as Simon rightly said, k equals minus 8. This means that our original derivative, our original equation is minus 8. Part after that then, guys, is that's our equation. Okay, now we're on to part is there a part C to this or B part 2? I think there's a B part 2. B part 2. Find the average value of f over the interval. Average value over an interval, right? So there's an equation for this, okay? So average value, anybody remember it?
Oh, 1 over b minus
1 minus b minus a. The integral of the larger integral, b is going to be 3, a is going to be 0. Thanks, Foley.
Right, I remember, yeah.
Okay. fx dx. Okay. So it's going to be 1 minus 3 times 0. Integral of 3, 0. And our function is now x squared minus 2x minus 8 dx. So it's going to be 1/3 times the integral of, what happens when you integrate x squared?
third x cubed over 3.
Yeah, so you add on a power. You add on a power to the old power, which is a power of it was the power of power 2. So now it's power 3. You divide by the new power, 1/3. This one here is it's technically going to be 2 times, it's going to be x squared, and then you're going to do 1 over 2, because 1 divided by the new power, and the 2 cancels with the half to just make minus x squared, because when you differentiate it's minus 2x anyway. And then finally here, minus 8x. You don't have to add on a constant this time. Why do you not have to add on your constant?
Because you have the original.
You have the original. Now, you can do this 2 ways. You can multiply in a third now and do your limits first, or sorry, do your limits after, or you can do your limits first and then multiply the answer by a third. So, right, a third times whatever's going on here. So, a third 3 cubed, a third 3 cubed minus 3 squared minus 8 times 3, and then close that, and then it's going to be minus just all zeros, aren't they? So no need to put it down even. It's all zeros because everything's going to turn to 0. Close that bracket, and then a third times all of that. It's going to be a third times minus 24, and then a third times minus 24 is minus 8. The average value over that interval is minus 8. Okay. Now this one here, guys, is in 2011 there's a bridge made. The bridge is based on a quadratic function. Quadratic function is n-shaped, therefore it has a negative x squared. We should all know this. Okay. Next thing, the arc of the bridge is in the shape of a parabola as shown. The length of the span of the arch is 48 meters. So you're talking about 48 meters from here to here. Now, there's something I know about this. If 0, 0 and 48, 0 are lying on the same they're on the same horizontal line, the maximum has to be dead center, which is going to be 24. Now, that happens a lot, but it isn't always guaranteed to happen, right? So we just in case, what we're going to do is we know it's the maximum point. Okay? So it says find the coordinates of C. Another word for C is max. When you see the word max in paper 1, what's the first thing you got to write down? dy dx equals 0. And if you're asked to prove it's a maximum, d2y dx squared is less than 0. Okay, so when you're asked this, you got to prove first derivative equals 0. Once you did the first derivative, then you're going to find out what is the You're going to use your value of x, put it into the second derivative, prove it's less than 0. We're not asked to prove it, we just want the point. So here's what you're going to do. Differentiate the first one, and you're going to get a point minus 0.02, 6x. Multiply the 2 by the number that comes in front of it. Yeah? Take 1 away from the power. Okay. The second one has an x in it, so if I differentiate 5x, I get 5. If I differentiate any number with an x beside it, I get what that number is. So it's going to be 0.624. And I'm solving this equal to 0. When I solve this, I'm going to get x equals 24. It's 24 times bigger. Is that alright? Now that I put in 24, I now have to find out the y value. Oh wait, it also wants me to, it actually does want me to prove it's, I'll just prove, just for the sake of it, I'm just going to prove that it's a maximum. Differentiate a second time, what happens? What happens when you differentiate a second time? And that's always negative. Less than 0. It's guaranteed to be a max. Now, find the... now, guys, to be honest, you can learn a lot about this, really, like... Yeah? What? Yeah, go for it. Now, lads, what we're going to do next is we're going to find the points. Now, what we're going to do... excuse me. What I'm going to do is I'm just going to take... once again, I'm just going to use this calculator for all it's worth. Okay? And what I'm going to do is I'm going to write down this formula here. So f of x equals minus 0.013 was it 13 x squared, right? Oh, 0, only 1 0, sorry, excuse me. So x squared, yeah. And then after that, I'm going to put down the 0.264 x, and I'm going to start at 0. I'm going to end at 48. And I know we'll call it step of 2. I don't think I'll be able to fit all that data in. Okay, now the middle is 24, isn't it? 24 is what we're looking for. So just go down. 24 is 7.488. So our point is 24, 7.488. Are we happy with that?
Are you allowed to just write that down?
Yeah.
You don't have to show any workings for it.
Don't have to show me workings for it. No, it's a point. See, it's just a y value. You get away with it. Okay. You can sure they let you use that calculator anyway, so it's grand. Once you put the right answer down, you put the wrong answer down, you lose the workings and the 10 marks off the workings. So usually it's good to show workings, but if you're dead confident, then you can save yourself a bit of time. Now, the perpendicular distance between the walking deck DE and AB is 5 meters. Find the coordinates of D and E. So the deck here, guys, starts from here to here, okay? And it's a height of 5. What does that mean for the y coordinate? The y coordinate is 5. Now, if I was being really smart about this, I'd be in the test and I'll just have a quick score for the 5s. I was like, look, oh, it's probably going to be 11, or in between 11 and 12. Do you see that? Yeah. So I'm going to be a bit sneaky about this. I'm going to say what I'm going to do is I'm going to go back here. I'm going to start it at 1. And I'm going to end it at 48 as usual. I'm going to do a step of 2. And what this will do is it'll get me the odd numbers I was missing out on. I went up in 2s last time around. Once again, I'm just going to have a quick look through. And I'm sort of seeing here that it's going to be 10 point something is my answer. So it's a decimal answer. Okay? So here's what's going to happen. We're going to get this equation, which is y equals minus 0.013 x squared. And what's the other one? The plus 0.624 x. And we know that the y value has to be equal to 5. So we're talking about some number and 5 here. And the second one is going to be some number and 5. So what we're going to be left with here is the minus b formula. Okay, because y is going to be equal 5. So y equals 5. We're going to bring everything over to one side. 0.013 x squared minus 0.624 x. Minus 5 equals 0. A equals plus 5, thank you. A equals this, B equals that, C equals this. I'm not going to do the minus B formula for the sake of time management. Expecting you to take care of it. Okay? So the two values we're going to get is actually x equals, remember I was speaking to you about 10, 10.16, and the x value is going to be 37.834. Now, once again, you guys will know you're right roughly, because you'll be like, look at 37, and then look at 39. It crosses 5 there, doesn't it? It goes beneath 5, so you knew that it hit 5 in between 37 and 39. Now, for the sake of the solution, they rounded off, so they said 10, 5 and 38, 5 as your 2 points, because it says to the nearest whole number. Is that alright? Now, part C, using integration, find the area of the shaded region ABED, and show in the diagram below, giving your answer correct to the nearest whole number. So what I can do is, just get simple marks on the board, lads. What I'm just going to do straight away is I'm just going to find the area of that rectangle. Easy marks on the board. So you can just say is area of the rectangle. Now we said that this point here was 10, 5, and we said that this point here is 38, 5. That means it's 5 high and 28 across. Means the area of said rectangle is going to be 140. Is that right? Now, next thing after that is I am going to integrate the blue region now. What I mean, I'll call it the blue region here. Going to integrate this region here. Is that alright? And then I'm going to take away my rectangle to find the little white region there.
You don't need that.
Okay, explain it short. The whole point, lads, is that I'm looking for this shaded region here. Yeah. My plan is to find out what the white region is first. By taking this blue region, take away the rectangle, I find the white region. Upon finding the white region, I will then integrate the whole thing to find the green region, and then I'll take the white region away from the green region to find my shaded region. Cool the billet? Okay. Now, what we have here is 140. We're next going to integrate the it's 10 to 38. Okay? So you're going to have a 38 on top, a 10 on the bottom, and what is we're going to integrate minus 0.013x squared and 0.624x dx. Okay? Integrate this, guys. Now what we're going to get, we're going to have to multiply this by, the power goes up by 1. So x cubed, and then it's going to be the old number divided by 3. Okay? The bit after that, that's now going to be x squared, and we're going to have to divide the old number by 2. And the old number by 2 is 0.312. These numbers are horrible, and what you're just going to have to do, guys, is you're going to have to sub in the numbers, take them away, and be ridiculously careful. So I won't go too much. I have the answer anyway beside me, but you're going to have to do something like this, bracket 3, and then it's going to be plus 0.312, bracket that, okay, and then what I'll do here, just 1 second, Ken. Okay, just going to nope, that didn't work out any faster than it should have. Nope. 1 second. Okay, so we're going to take away this one on the bottom. So we have to do the same thing twice, except fill in the brackets and a big minus sign on the outside. So does everybody understand? It's the top bracket minus the bottom bracket, and we're going to plug it in. So that's your 38. That's your 38 there. That's your 10 there, and your 10 there. So upon doing this, you're going to put all that into the calculator, and you're going to get 185.8827 meters squared. Okay, this comprises of the this green region I had done a second ago. I'm going to take the 140 away from that. I'm going to take away the 140. Anyone else? Take away the 140. We're going to be left with the white region, which is 45.8827. Now, guys, brilliant thing about this is I can reuse a lot of my work. So what we can do is we now have to integrate the the big region, which is the whole thing, this full region here, and we're going to take away our 44 to get our answer. So what I can simply do is I just have to change the limits. It's now 0 to 48. So if you will, in the test, you're just going to be looking up at the work you just did. 48 0, because as Connor rightly said, because the second one's a 0, I can just scratch that off. It's gone. And then anywhere I see a 38, I'm going to change it to a 48. So 48 and 0, and then just change this 38 here into, oh dear, change it into a 48, and then same integration, same thing, just be really careful on the calculator. And when I do this, I'm going to get my 239.616 meters squared. I'm going to take away my
95.
my what?
95.
My 45.8827. And once I'm going to take them away from each other, I'm going to get 194 meters squared to the nearest meter squared. Okay,